Hi guys, you're welcome to my channel. Today I want to derive the equation of simple harmonic motion, especially that of the spring mass system. Now, when you talk about a simple harmonic motion, you all know that it's a motion of an object that acceleration is directly proportional to its displacement, or you say it is what? A motion of an object whose force is directly proportional to its displacement. Understand that fact. And you should know that a force that causes simple harmonic motion is a restoring force. That is the second fact that we need to know about a simple harmonic motion. Now, let's quickly see. If I have that this is a spring, and here is the equilibrium position of the string. This is the mass that will apply to the string. The applied force is acting in downward direction, while we have the restoring force that will cause the body to keep oscillating, ready to take the body to the equilibrium position. So the simple harmonic motion, that is the restoring force, is given to be negative kx. Are we together? Where this negative symbolizes that the restoring force is opposite to the applied force. So here is our first equation in this class. So if this is equation 1, another thing that we need to understand about a body that is performing a simple harmonic motion is that the kinetic energy and potential energy, they keep changing to each other. That is, potential energy change to kinetic energy and kinetic energy change to potential energy in the same pattern. Therefore, our potential energy is given to be 1 over 2 kx squared, and our kinetic energy is 1 over 2 mv squared. So this is equation 2 and this is equation 3. Now watch, I would like you to understand something, that at a point where your x is maximum, that is when the displacement is maximum, is what we call the amplitude, and at the same time velocity is said to be max when displacement is equal to 0, and also acceleration is said to be max when displacement is max. So when velocity is max, acceleration is actually what? 0. And maximum velocity results to 0 potential energy, and maximum displacement results to 0 kinetic energy. These are little facts that you need to understand before we proceed with the derivation of what? The equations. This is the third equation now. So let's go to the fourth equation, and that fourth equation is talking about the total energy of the system. So when you talk about the total energy of the system, we have that the mechanical energy equal potential energy plus kinetic energy. So our mechanical energy is 1 over 2 Ka squared equal 1 over 2 Kx squared plus 1 over 2 mv squared. So 1 over 2 is common. If I multiply through by 2, I will have Ka squared equal kx squared plus mv squared. So I'll call this equation 4. So from equation 4 now, we can now start looking at different things about this. You understand that when x is maximum, then the potential energy of that system is equivalent to the mechanical energy. And when v is maximum, kinetic energy of that system is equivalent to mechanical energy. Okay, so if that should be the case, let us find the maximum velocity formula for maximum velocity of that system. So the formula for maximum velocity is said to be maximum when what? Our displacement is equal to 0. So if displacement equals to 0 from equation 4, we are going to have that mv squared equal ka squared. Am I making sense? So v squared equal k divided by m multiplied by a squared. So taking the square root of both sides, v max equal the square root of k divided by m a squared. So we therefore have that our maximum velocity is a multiplied by k divided by m. So this is the fifth equation. So we're going for the sixth equation now. So the sixth equation is about the velocity at every instance. That is, we are not talking about the maximum velocity now, but want to know the velocity at an instance. So we just come back to equation 4. So from equation 4, we can say Ka square equal Kx square plus mv square. So from here now, I'll take this to the other side. I have Ka square minus Kx square equal mv square. So k is common here. If you factorize it out, you therefore have a square minus x square equal mv square. So divide both sides by m. We have v square equal k divided by m into a square minus x square, like this. So velocity at all instance or any instance is k divided by m into a square minus x square. Now this is going to be our sixth equation. Are we together? Now there are some cases whereby you'll be given a question that you might not be given the spring constant and the mass of that particular spring, or the mass that you apply to the string, you might not be given, but you'll be given the maximum velocity. How do you calculate for velocity at a point when you are given a maximum velocity? We can do that from equation 6. What we just need to do is that we factorize out a square. So if we do that, we are going to have k divided by m multiplied by a square into 1 minus x square over a square. So if you look at this now, if I open this bracket with a square back, I will have this. So we've not done anything wrong. Correct? If that should be the case, for better understanding, I will split this equation. I will now have the square root of k divided by m a square multiplied by the square root of 1 minus x square over a square. So if you look at this now, this is the same thing as saying a root k divided by m into the square root of 1 minus x square over a square. So we close the bracket. So if you look at this now, a root k over m is the same thing as the maximum velocity. Thus, velocity at every instance is v max, the square root of 1 minus x square divided by a square. So this is going to be our seventh equation. So that's equation 7. And the next thing that we need to consider again now is the acceleration. So we are looking for the maximum acceleration now. So for us to get the maximum acceleration, what are we going to do? So we just quickly recall that f is equal to ma, also f equal kx. So if I equate these two now, so I'll be having what? ma equal kx. So a equal k divided by m multiplied by x. So this can be our acceleration at any point. Are we together now? So if you are looking for maximum acceleration, for acceleration to be maximum, your displacement must be maximum. So when displacement is max, our result is amplitude. Thus, a equal k divided by m multiplied by what? Amplitude. This is going to be our maximum acceleration, and this is equation 9. Are we together? So now that we have equation 1 to 9, before we move down to equation 10, which we are going to be talking about the frequency and the period of oscillation, I would like us to move into that now. But you have to understand something first, that the frequency is the number of cycles that a body completes in 1 second, and also the period is the time that takes a body to complete 1 cycle. So if that should be the case, I can then show that if I have a cycle like this, the velocity is going to be the distance all over what? The time. So if it takes this body, the total time, the perimeter of this particular circle is given as 2 pi r, and the time that will take you to complete this is the period, which is t. Are we together? So if this should be the case, I can then say, if you look at this here from here, are we together? For a body, for a circle like this, are you getting this? So this is the radius of this circle. So from the radius of this circle, this represents the maximum displacement of this. You can check my video on simple harmonic motion to understand this. So R is equivalent to our amplitude. So we have that V equal 2 pi A divided by T. So if I cross multiply, I will have that T equal 2 pi A divided by V. So are we together? Good. If we are together, so I can just come down to this place. If this is my V, are we today? Are we there? V now is a velocity, right? And we have been able to show from here. Okay, I can decide that from here, where I have my V max. That is, V max is equals to what? Our V max is given to be A root K divided by M. So if I have this, I can just like make my A the subject of the formula. So if I make my A the subject of the formula, I will have that A is actually equal the square root of K over M multiplied by V, like that. So I will substitute for A in this equation. So I will have that my T equal 2 pi divided by V multiplied by A, which is the square root of K divided by M multiplied by V. So V and V would cancel. Then I will have my period to become, okay, permit me to clean this. So my period is going to be 2 pi, the square root of K divided by M. And this is our 10th equation. So we know that period and frequency, they are reciprocal of each other. So our frequency is just going to be 1 over 2 pi the square root of M over K. And this is equation 11. Okay, so we've gotten for frequency and period. Also, you need to understand that in a nutshell, period is also the same thing as the time divided by the number of cycle, and frequency is also the same thing as the numbers of cycle divided by what? The time. This is what from the definition of period and from definition of frequency. Do we understand this now? Good. What other equation do we need to know as regard the spring mass system? Another equation that we need to know is the equation given to the, okay, for instance, if I plot the graph of a body that is performing a simple harmonic motion, it's going to give me a sinusoidal graph. I can decide to make it a cos function, or I make it what? A sine function. Like currently here now, this is a sine function. So you can also decide to make it what? A cos function, like this. So it's still going to range within A and negative A, which is our maximum amplitude. I did a better explanation on this in our previous class, which I'm going to drop the link in the description box below. You can do well by watching that. So how do I go about this? So I would not like to say much story here, but I want to show you the rudiment of the equation. So let's see. If I have a circle like this, I can use this circle to represent the way the body is oscillating. So this is the horizontal, which is the diameter, and here is the amplitude. Are we together now? So this place is our displacement x. Are we together? So if that should be the case, I have here to be my angle theta. Thus, I will have that x is equal to opposite. Okay, I'll have that my cos theta rather is equal to adjacent over hypotenuse. So if I cross multiply, I will have that a cos of theta is equal to x, which is our position. Are we together? So I'll call this one equation 12. So if this is equation 12, now take for instance, if this is given as our displacement, what is the value for theta? Our theta is the same thing as omega t, because omega is the angular displacement per unit time. So if I cross multiply from there, I will have that theta itself is omega t. And you will recall that omega itself is 2 pi f. In case need be, we have that omega is 2 pi l. So if we put it here now, we have that the v, we have, let me take it like this so that I won't skip gradient. So x equal a cos of omega t. So if I'm looking for velocity of this body now, I will just differentiate this with respect to t. The x dt is going to give us negative omega a sine of omega t. Are we together? So omega is 2 pi f, so I have that v is equal to negative 2 pi f a sine omega t. Now, I would like us to see something here clearly now. 2 pi f, our f now is frequency, which is the same thing as saying 1 over 2 pi square root of m over k. So I can just like slot it into this equation. If I do that, I will have that my v is equal to, this is going to be negative 2 pi, right? Negative 2 pi multiplied by frequency, which is 1 over 2 pi, the square root of m over k. Are we together now? So if I have this, then multiply by the amplitude sine omega t. Okay? So if this should be the case now, we can have that 2 pi and 2 pi would cancel each other. So if 2 pi cancel the 2 pi, I will have what? M over k multiplied by my amplitude. And that will give me what? Can that give me velocity? Okay? Will that give us velocity? Okay? If I cross 2 pi here is okay, correct. Okay? So, V now is equal to A root M over K sine omega t. So if I have this, I think something is wrong somewhere. It seems something is wrong somewhere. Okay, let's go back to this equation and see what we've done wrong there. Okay, we have that V is equivalent to 2 pi A divided by the period of oscillation. So if I cross multiply, I will have that T is equal to 2 pi A divided by V, right? So if I have this, I will make A the subject of the formula from here. If I make A the subject of the formula from here, I will have that, we have that V is also the same thing as A square root of K over M. Okay, if I'm not mistaken here now, from here, okay, I have to multiply both sides by the reciprocal of that, which is M over K, okay, and this is equal to A. So if I put that here, I will have this to be multiplied by V square root of M over K. So there is mistake here. So this is supposed to be K over M, and here supposed to be M over K. So kindly note that. So it shows that this is supposed to be K divided by M. So this is going to give us what? V equal negative V naught sine omega t. And this is just our velocity. Do we get that now? So the next thing we have to look at now, please take note of that correction. So next thing we need to look at now is that we have to differentiate this again to get our acceleration. So the v dt is going to be what? Negative, this will be 4 pi square f square a cos of omega t. When you differentiate that again. Okay, so we have that the v dt is equal to negative 4 pi square f square a. What are we going to have? Okay, in this case now, I will substitute for f again. So this is negative 4 pi square. Our f is going to be 1 over 2 pi, the square root of k over m, multiplied by a cos omega t. Are we there? Remember, this is our equation 13. Okay, so if this should be the case now, I can then show that a, which is equal to negative 4 pi square multiplied by 1 over 4 pi square k over m, because this is all square. Are we together? multiplied by A cos of omega t. This and this would cancel. So K over M multiplied by A will give us A max. So we have negative A max cos omega t. So our answer for acceleration is negative A naught cos of omega t. So it's as simple as this. So this is equation 14. Okay, so at this junction, that is that about all equation that has to do with spring and mass system. Don't forget to subscribe to this channel, like this video and share within your friend. Thank you.